All right, welcome back. Now, L'Hopital's rule only applies to sort of the 0 over 0 case or the infinity over infinity case, but it turns out it also can be adjusted so that it handles other of these what are called indeterminate forms as well. Here, we're going to figure out what happens if your problem is sort of a 0 times infinity. How do you handle that? And essentially the trick will just be this. You can take part of your equation and rewrite it as 1 over itself. Okay? Because that's the same thing. All right? That's the only trick. That's how you handle all these problems. All right. This is best done by example. So let's do the limit as x goes to 0 from the right of x log x. Now the x part is converging to 0, and the log x, remember it has an asymptote there, it blows up to negative infinity. So it's negative infinity, but in these problems usually just write infinity. Okay, so it's a 0 times infinity problem. L'Hopital's rule does not apply, so we can't use L'Hopital's rule. Okay, but we can rewrite this in a way that makes L'Hopital's rule applicable. And the trick is to rewrite this x using the trick that I just mentioned. To write this as the log of x all over 1 over x. Okay? Because 1 over x is back to x. Now, the numerator is still converging to negative infinity, and the denominator, 1 over x, well, as x goes to 0, that's blowing up to infinity as well. So it's infinity over infinity. And this form is legal for L'Hopital's rule. So let's do it. So it's the limit as x goes to 0. In the numerator, derivative of the log is 1 over x. Thinking of 1 over x as x to the minus 1. The bottom is minus 1 all over x squared. That's the derivative. And then you manipulate your fractions here. You would have x squared over x with a negative. So you end up with just a minus x. And that limit is easy to read. It goes to 0. So that's the answer. All right, that's how you handle 0 times infinity. See ya.